When we first started researching for our project, we were struggling really on ideas on what to do, sort of butting heads really. I wanted to do something materials related. Amna wanted to do something that was related to biology, being a biologist, and Roman was into the whole pharmaceuticals industry. So the first problem was finding something that linked all of our wanted fields, and this is what came out of it.
So our idea was to research into the treatment of atherosclerosis. Atherosclerosis is potentially a serious disease characterised by the deposits of fatty materials into your arteries. Why is it a problem? Well, the plaque can cause the arterial walls to harden and gradually narrow, which is particularly hazardous to the human body, restricting blood flow through the body and potentially damaging organs. However, arteries also narrow over time with age, and further, if the plaque ruptures, it can also cause blood clots. Clotting then could potentially cut off the blood supply and then trigger myocardial infarction or ischemic strokes. How can we prevent it? Today in modern medicine, we've just researched to the extent where we can just bullet point it to 5 points that everybody can follow. So you can eat healthily, stop smoking, take regular exercises, lose weight, all these kind of things to prevent it. However, we still need to understand cholesterol for the people that do develop the disease and address it. The fatty buildup of the deposit known as cholesterol is a natural substance made by our liver and widely found in our tissues. However, the concentrations of the cholesterol is what promotes the disease. Cholesterols can be found as high-density lipoproteins or low-density lipoproteins. Low and high-density lipoproteins both transport cholesterol in the blood, but the main function difference between the two are the delivery of the cholesterol to different parts of the body. Low-density lipoproteins bring cholesterol to the cells throughout the body and cause build-up through your artery walls. High-density lipoproteins, on the other hand, can briefly benefit your health. They transport away these fatty deposits.
Currently, stents are used to solve the problem of blocked arteries, especially the transheart catheter. They are placed in the coronary artery and act as a support, which keeps the vessel open, returning blood flow back to normal. The femoral approach is used to insert the stent, and the location of the blockage is found via an angiogram, and a guide wire is used to thread and is threaded to the blocked area. When the catheter reaches the blockage, the balloon stretches and expands, which allows the valve to be opened to its maximum potential. When the balloon is inflated, it pushes the plug against the artery walls. This process happens repeatedly. The balloon is then deflated and removed along with the guide wire, leaving just a stent in the artery. So here is a diagram showing the process of the stent being inserted and the function of it in the blocked artery. Stents are made to last for life after being inserted, and therefore it is important to consider what material is used. The catheter has a leaflet shape, which optimizes the hemodynamics and durability of the product. That's made from a medical grade stainless steel. However, looking aside from the pros of the product, stents have many problems. 40% of people who have stents are at a higher risk of more blockages and blood clots in the treated area due to too much tissue growth. When the catheter, the stent itself could also reclose, which results into another blockage, meaning another procedure will have to take place. Other problems encountered include bleeding in the treated site, damage to the blocked vessel, and damage to the kidneys from the dye used at the beginning of the process, as well as allergic reactions and infections. The main problem we came across was that the plaque was not removed fully from the artery, but instead just pushed against the walls. And so we found a solution to this.
We used nanomaterials as a way to solve the issue of the buildup of plaque within the body to fix it. Cryotherapy is the name given to the practice of gold in medicine, and it's used widely in high infection risk areas such as dentistry, implants in the ear, and pacemakers. The reason that it's so good for use is because gold is highly unreactive, making it very biocompatible within the body, and it also has significant anti-inflammatory properties. In 2007, Purdue University released a detailed study about their use of nanogold to detect breast cancers. And the reason it's able to do this is because nanomaterials have very specific light properties as opposed to the non-nanomaterials. The reason for this is because when light is shone on it, because the materials are so much smaller, the light can only be reflected in one direction, giving off different wave particles as we would see it in the many different directions. We are going to utilize these same sort of technologies to use the nanorods as a delivery system to take the HDLs to the LDL sites. The body already has an effective system of breaking down these fatty plaques, and it does this using the HDLs. HDLs in themselves are a nanomaterial, and their size can vary greatly from about 2 to 7 nanometers. And when they interact with LDLs, the LDLs will transfer triglycerides to them and in exchange for cholesterol esters. This matures the HDLs, making them larger, and they are then able to carry them to the liver where they are excreted as bile. The issue that we have, though, is that the body can't keep up with the rate that some people build up this plaque, so the HDLs are not delivered in a significant amount enough. So the idea is to use these nanorods to deliver the HDLs to where they are needed. The nanorods are given the rod shape to increase their surface area, because by increasing the surface area, we are able to transfer more HDLs to the site where they are required. And this is the optimal method for breaking down the plaque, as it utilizes the body's own resources. The next thing that we'd need to consider, though, when using this is to ensure that the HDLs are disassociated from the nanorod at the site where they are needed and not just randomly in the body, and to cap the nanorods as well, because to prevent other particles in the body from associating to it.
Yeah, that's it.
Okay.